Projectile Part 2. This is a continuation of Projectile Part 1. Before I do Part 2, I'd like to make a summary of what we have in Part 1. So Part 1 summary is this. So I have a projectile. Okay. And this is the ground. So in Part 1, I have found the time. The starting point is time equals 0. And when it falls to the ground, the time we found in Part 1 is 2 Vy divided by 9.8. Now, Vy is the y component of the initial velocity. This is Vy. The time at the maximum height, this is the maximum height. What is the time here? The time is Vy divided by 9.8. Now this time is just half of this time. And we also found in Part 1 the half maximum point. This height is half of the maximum height. And I have 2 points. They are both half maximum height. So this height is half of this maximum height. The time here is from Part 1 we have this. Okay, this time is this number multiply this time. And this time is this is y. Okay. This is the summary of Part 1. And in Part 2, what I want to find the velocity at this point, the velocity at this point, the velocity at this point, the velocity at this point. To do that, let's label these points. So let me label this initial point be point A, and the final point be point B. At the maximum height, let me label it point C. At half maximum point, I have 2 points. Half maximum here, half maximum here. I label this as point D and point E. So what do I want to find? I want to find V at point D, at point B. So I want to find V at point B. So I use a subscript to indicate the location B. And also I want to find V, the velocity at the maximum height, so which is C, Vc. And I want to find, similarly, I want to find Vd and Ve, okay? Oh, sorry, Ve. Okay, I want to find these. To find the velocity, I really need the x component at the initial position. So let's say the x component is, let's choose a special value for initial velocity. So let's use some numerical values. Say Vy is, let's say Vy is 9.8. And also let's say Vx is also 9.8. Now, Vy is my y component at point A, and I have a Vx here. So this is my Vx. Okay. Let's say both Vy and Vx are 9.8. Remember, in a projectile, the horizontal velocity does not change because there is no acceleration in the horizontal direction. This means Vx at point A is 9.8. This is my given value. I choose a special given value here. Since the x component doesn't change, so my x component of velocity at point D is also 9.8. Similarly, Vx at point C is 9.8. And Vx at point E is 9.8. And Vx at point B is also 9.8 because the x component of velocity does not change. Now let's find the velocity at B. Find velocity at D. So what is the x component? I already know at point D, the x component is 9.8. So all I need is to find the y component at point D. What is the y component at this point? I use the kinematics equation. V equals V2 is V final is equal to V initial plus AT. So the V initial is this, y component is Vy. That's my initial vertical velocity, and plus acceleration times time. So what is this? So Vy is 9.8. So I give it a special value, so 9.8. The acceleration for vertical motion is 9.8 downward. So I write minus 9.8 t. The time is the time at point D. What is the time at point D? It's this. So this is 2 minus root 2 divided by 2 multiply Vy is 9.8 divided by 9.8. And you work this out. Of course, you use a calculator. Work it out. What is this? It is equal to 6.86. 6.86. Here, all these are numerical numbers, so you can find the answer, 6.86. Now, once you have that, you have the velocity. So the velocity is Pythagoras theorem. V at point D is Pythagoras theorem. And you use a calculator. The result is this. Then what is the direction? Now at point D, the velocity is the tangent at point D. So the velocity is tangent at point D. It should be this, right? So this is 9.8. And this is 6.86. So this is 11.7. So what is this angle? So this angle is tangent theta is my y component divided by my x component. And this is 0.7. And then theta is arctangent. And it is 35 degrees. So this is 35 degrees. So I have velocity at point D now, direction and magnitude. Now next I want to find the velocity at point C, V at C. So C is the maximum height point. I'm sorry, do you see that? Velocity at C. At point C, Vy at C is 0 because that's the maximum point. Therefore, the only velocity is the x component. But the x component is the same, 9.8. Therefore, V at C is 9.8. So it is point C here, the velocity is 9.8. Oh, I just realized that when I wrote this part, my paper may be outside view, so you do not see it. Is that right? So I need to repeat this. Just say it again. So for velocity at D, the x component is 9.8. The y component, I use the kinematics equation. So final velocity is initial velocity plus at, and initial velocity is 9.8, which is this. This is my initial velocity. And at point D, initial y velocity minus at. A is down 9.8. The time is this. The time is this. But I already gave Vy the value 9.8, so I have this. And you use a calculator to do the numerical calculation. I got 6.86. And the magnitude of the velocity at D is, now you see, x component, y component. The magnitude is Pythagoras theorem, so here. So this is the result. And once I have the magnitude, I need to find the angle. The angle tangent this angle is y component divided by x component. So I have this, and I do the anti-tangent value. So inverse tangent is 35 degrees. So this is 35 degrees. And then at point C is quite easy. At point C, you do not have the y component. It is entirely horizontal. Therefore, I have 9.8, since the horizontal component doesn't change. So now I need a velocity at E. Velocity at point E here. This is also the half maximum height. So velocity at E. But do I need to repeat everything? So you can write down the x component, 9.8. You can also use the kinematics equation to find the y value, to find the y component of the velocity here. You know the time is this. So you use this time and use the numerical value Vy is 9.8. You find the time and you can find the y velocity. But you don't need to do that because point D and point E are symmetrical. So you already have the velocity at point D now. So at point E, you don't need to do that. It is this. At point E, it is this. Symmetrical, so this is 11.7. And this angle is 35 degrees. You don't need to repeat the calculation. Just use your physical concepts. This is symmetrical with respect to that, except one is up, the other one is down. Similarly, do you need to find the velocity at B? No, you don't need the velocity at B. No, I don't mean you don't need. I mean you don't need to calculate it. It's symmetrical. So at point B, it is symmetrical with respect to A. So at A, it's pointing upward. At point D, the velocity is pointing downward. Just use symmetry. So the x component is 9.8. The y component, instead of pointing up, is pointing down, and it is 9.8. So 9.8, 9.8, so the angle is 45 degrees. You don't need to do any calculation. And this, now you need to do this. Yeah. This is the Pythagoras theorem. So how big is this? 9.8 square plus 9.8 square. Take square root. And it is 13.9. So I have solved this part 2 problem. I hope you follow everything here. Thank you for watching. Bye.